Let's discuss the experiment of resonance tube. It is used to calculate speed of sound in air. Here we can see a typical experimental setup of a resonance tube experiment, in which there is a long tube T which is filled with water. At the bottom there is a narrow rubber tube connected with a reservoir R. Obviously, as the two are connected, water level in reservoir and the tube will always be same. And to measure the water level, there is a fitted scale S, on which we can measure the reading of the length of air column when the level of water is lowered by lowering the reservoir. There is a mechanism by which we can lower down the reservoir level or we can raise it up. Correspondingly, the water level in tube also will go down or raised up along with the reservoir. Now to start with experiment, we bring a tuning fork near to the mouth of this tube, due to which the air column above the water level will start oscillating. And we gradually lower down the reservoir up to a level when the tuning fork will start resonating with the available air column. And as it is lowered down, gradually you can say the length of air column will also increase. But stationary waves will establish only when the length of air column will match with 1/4 of the wavelength. And this we can detect by increase in sound loudness, because once stationary waves are established in the tube, the amplitudes of oscillation will start increasing, because the oscillation energy which is supplied by the tuning fork will be stored in the air particles producing stationary waves. So, whenever we lower down the level, as soon as we detect a continuous increase in loudness of the sound from the air column, we can just consider it a point of resonance. Now in this situation we can measure the length L1 of the air column on the scale when it is lowered down. Now, after this length L1, which can be taken as the first resonance length, we can further lower down the reservoir till the next resonance occurs. And we know that next resonance occurs when the length of air column available will be 3/4 of the wavelength. As again resonating situation occurs when, at open end antinode is there and at closed end next node will be obtained. That means the water level is further reduced by 1 loop length. Thus situation is similar to that of a sonometer experiment, in which the clamps are displaced for next resonating length. Here water level is lowered down for next resonating length. So here we can say if L2 is the next resonating length, here we can see experimentally L2 minus L1 will be lambda by 2. And in this situation the wavelength lambda which we have experimentally calculated is twice of L2 minus L1. And from here we can find out sound speed by using the relation speed will be frequency of tuning fork multiplied by wavelength. And the frequency of tuning fork is already embossed on tuning fork, which is known. So it can be given as frequency of fork multiplied by twice of L2 minus L1. This is the expression by which we can find out the sound speed in air. This is the experimental speed we have calculated. And theoretically its speed can be calculated as root of gamma RT by m. And using this expression, the theoretical speed can be calculated and we can compare the experimental and theoretical value. And if there is any difference we can analyze the factors due to which it is happening. So this is the way how experiment of resonance tube is carried out. To measure the experimental value of sound speed in air,